Hey guys, welcome back to my channel. Today is a continuation of a previous video whereby we started modeling the geometry to use in analysis. Today I'm going to model the bolt and nut. This bolt and nut. Yeah, let's have fun. Okay, our remember our nut will be on this face. Nut. Sorry, our nut will be on this face, the bottom face. The bolt head will be on this face. Therefore, let me first hide the lower nozzle. Let me use the upper nozzle, and I want to model using the midi plane. Therefore, select the midi plane, sketch, and you can look at to be normal to you. Zoom at this far corner. Now we want to sketch a circle here. Go to sketching, circle. Yeah, make sure you see this a C. The C icon is symbol. The C symbol is have to be displayed. Okay, that's my circle. Dimension, we need diameter. Okay, diameter, and we want to use an M8. M8 is approximately 0.3125 inches. Yeah, go back to modeling, activate this sketch because we want not to define with respect to this sketch. Go back to sketching, dimensions, vertical from this point to this point here to this one here. We need 0.625, 0.625. The sketch becomes blue to show that the sketch is a fully defined, to represent a fully defined sketch. Then we need to extrude. Okay, this circle, apply. We need to extrude direction here. Asymmetric is whereby you define dimensions of each direction. Symmetric, for the symmetric they are the same, left and right are the same, but here for the asymmetric they are not the same. Therefore, depth 1 and depth 2 they are not the same. We need 0.562. These are the dimensions you can get from the fasteners catalog. Okay, they are not supposed to be so precise because they affect simulation less, it has less effect. Therefore, but the bolt head, this diameter is very important for you to define the precise dimension. But for the height, not so important. Okay, the direction I want to use 0.875. Okay, now we can generate. You can still, I like zoom to fit, rotate, then zoom to see the board. As you can see, this is the bottom side with a 0.875. This is the top side. This is where we are going to put our head. This side we're going to put our nut. Let's now sketch the head. We need a plane here. Therefore, select this plane, new plane. You can either right-click, insert a plane, or you can just use this icon. Therefore, let me use the icon. Save time. Plane from face. Okay. Select the face, this face, apply. Okay. Now we need to sketch the bolt head here. Therefore, select the plane, generate. Now the plane, sketch, go to sketching, circle. Before you go to sketch, okay, let me use that Z. Show you another method. You can just, if it is isometric here, you can just click Z axis to be normal to the sketch plane. Therefore, we need a circle here. The circle is already selected. Okay, please select again. Circle here. We need one circle and another one. Make sure this T icon is indicated to represent tangency. Now go to dimensions. Dimension this circle, the bolt head diameter to be. Let's use 0.47. Okay, 0.47. Go back to modeling. Okay, then go to extrude. To extrude this, apply. Don't add material. Yeah, let's add the material here because we want them to be the same, to be one part. But here on the direction we need to take 0.5. This is 0.56 to the length by which we extruded minus the thickness of the fridge 0.25, which will be left by 0.31, okay, 0.312. Yeah, got is 0.562 minus 0.25. Okay, but the direction we want to reverse generate. Let me double confirm we used the right dimensions. Yeah, it is okay because they have to touch this head and this surface. They have to touch. They are touching. That's good. Let's model the nut on this side. Okay, going down to put a plane here and offset the plane because we want this nut to be in con to be touching the lower nozzle. Therefore, the nut will be somewhere here. Therefore, let me insert a plane. Let me use a from face. Select this face here. Can rotate a little bit. I want to select uh, this face icon. Okay, that's face. And now we want to transform this plane. Let's transform here, z-axis. We will transform by negative z-axis because you can see z is facing up. Want to go the other direction, 0.625, which is the same as 0.875, the total height minus the thickness of this fledge. You get this. Okay, generate. You can see now it is already lying on the nozzle. Let me zoom here. Now we need to sketch on this plane. I was to teach you, we can right click on the plane and look at to be the normal to the plane. Okay, we need a sketch here. Let me hide the one nozzle. I can hide all of them. We need a bolt. We need a design a nut. Therefore, we go to sketching here. We need a polygon and sketch it here. Okay, make sure that it is horizontal. You can see the H icon there, and we need this height to be vertical to be 0.4, the same as the bolt head, which is the 0.47. 0.47, yeah, the same. Then we need another circle. Let me retrieve to see this. We need a circle. Go to draw circle. Okay, look at until when you see the T becomes tangent, then go to extrude this sketch by 0.312, 0.3125. Then we can generate. Okay, go isometric. Isometric is here. No, it is okay. That's my bolt. And this the space between these two, it is a space whereby we are going to have our nozzle. Let me show the mid nozzle. Show. That's my mid nozzle. This space remaining is for the lower nozzle. Okay. This space is very important because we are going to use that space in this surface in actual simulation. This is the effective surface we need, the most important surface. But this surface here, it can be long or short, it has less effect in the simulation. Therefore, we need to separate this surface from the overall surface. How do you do that? Let me first of all hide the sketch hide. We need to project. We want to project this circle onto this surface. Right now it is one surface. Therefore, this surface will be very important. Let's project to make it now so that we can be able to separate. So that during the simulation we can now define this surface. Yeah. If we go to project projection, we want to project what? An edge on a face. Which edge? This edge. Apply. Target face, base face. Apply. Okay, now the face is formed. Generate. Seems there's some error. Face on edges on a face. Okay, let me delete it. Programmatic geometry, incomplete projection. Okay, let me delete it for now. So yes. Okay, let's first combine these two bodies to become one body. Then we have to make sure this body is not combined. Let me go back to this body. This extrude 4. You don't add the material here. You add frozen. Okay, that's one of the error. The reason why our tool didn't function. You add frozen. Then we need this one to go to Boolean. Unite this. It is already united. Good. It's already united. Then we don't need Boolean now, because this one is one body. Let's now go back to tools, projection here. Project what? We want to project an edge on a face. Which edge? This edge. Apply. Target face, this face. Apply. Then generate. Yeah, that is functional. Now we have our one face here and another face. You can see now the nut becomes translucent. Okay. Yeah. Now we can be able now to show all other bodies. Go isometric. Yeah, go isometric, zoom to fit. Okay. Show all bodies. Okay. Thanks so much for watching. In our next video, I will now illustrate how you can be able to pattern these nuts and bolts. Then I will illustrate how you can have some holes. We need holes through the flange. Yeah, and then we are going to model the flange, the flange, because these two flanges we need a rubber seal like O-ring. We are going to model the surfaces of these two, so that in the next video, part 4, we start the actual simulation. Okay, see you in the next video. Thanks so much. Kindly subscribe. See you.